Math properties are rules that tell you how numbers and operations work in math. And they're there for you to use to help make solving a problem easier. So it's not that you have to use them, it's that they're tools to aid the mathematician. So if we were to look at this problem, -8 plus 13 plus -2, our normal inclination would be to add them in the order that we see them. However, we also know that it's easier to add integers that have the same sign, because all we do is add their absolute values and put that same sign on them. So if we were to do some rearranging and regrouping, we might want to take the negative numbers and add them together and put the different sign at the end, so that when we group them, we would actually group the ones with the same signs first and add those numbers. The first property we want to talk about is the commutative property. The times when you might want to choose them would be if all of the operations were addition, or if all of the operations were multiplication. Because that's the first thing we want to decide when we're looking at our math properties, is when that particular property might be useful to us. And then we're going to look at the definitions. So the definitions, depending on whether it's an all addition or an all multiplication problem, the definitions are adding numbers in any order will give you the same sum, or multiplying numbers in any order will give you the same sum, which means that you can take an expression such as 4 plus -5, and it would really be the same thing as -5 plus 4. You would get the same result. Similarly, in our multiplication problem, 14 times 5 would give you the same result as 5 times 14. The next property is the associative property. And in the associative property, again, we're going to look at when we might want to use them. And it's like commutative property, would be used if all of the operations in the expression are addition, or if all of the operations in the expression are multiplication. And then again, our definitions would be for addition, if you're adding numbers in any groupings, you'll get the same sum, or multiplying numbers in any groupings will give the same product. So looking at our addition example, if we look at -8 plus 13 plus 7, again, normally we want to think that we would group the first two and add them first. But really, it's easier to add integers that have the same sign, so we would add these two first and add that sum to the -8 in the end. Same with our multiplication problem. Rather than just multiplying in order from left to right, to make this problem easier for us, we might want to multiply 5 times 2 first, because that makes 10, and 10 times any number just means adding a 0 to the end. So that's a way of using the associative property to make the math easier for us. And the third property that we'll talk about today is the identity property for addition. Now, obviously, we would choose to use this in addition operations, and the definition is that adding 0 to any number will not increase or decrease the number. So it's obvious that -5 plus 0 will give you an answer of -5, because if we add 0 to anything, it's not going to change that number. What's not so obvious from this is that even though this is an addition property, subtraction is really just another form of addition. We haven't gotten there yet. And so subtracting from 0 from a number really is going to give you the same result. So negative 5 minus 0 will also not change the number, and you'll still end up with negative 5 for your answer. So we're going to keep that in mind with our identity property for addition, that adding 0 or subtracting 0 from a number will not increase or decrease the number. And continuing with more on the identity property, let's remember our opposites. 5 plus negative 5, 2 plus negative 2, 6 plus negative 6, a number and its opposite. If we look at this problem, we can see that they have different signs. And since they have different signs, we would subtract their absolute values. So the absolute value of 5 is 5. The absolute value of negative 5 is 5, which means we'd really just be doing 5 minus 5, which is 0. And in fact, this is going to be true for all numbers and their opposites, because their absolute values are going to be the same number, and when you subtract a number from itself, you're always going to end up with 0. So really, the thing to keep in mind when you have any number plus its opposite, the sum will be 0. Okay, so let's apply our properties now. Here's our first problem, negative 12 plus 13 plus 4 plus negative 6. We could work this problem in order from left to right, and we would get the correct answer, supposing that we did all our math correctly. But to give us a little edge, a little increased advantage, or help in getting the correct answer, we want to try to do it the easy way. And it's easier if we add the ones that have the same signs first. So if we were to take negative 12 and add negative 6, and then put the positive ones together also, so we have used the commutative property to rearrange our numbers, putting the ones with the same signs next to each other. And then next, we use our associative property to group the ones that we want to add together, and we add those instead of adding in order from left to right. Same signs, add their absolute value, keep the sign, and now we're left with a single problem with different signs. Different signs, look for the one that has the largest absolute value. It will be negative. Subtract their absolute values, and you have 1. And let's try this problem. 19 plus negative 3 plus negative 19. Here I can see that I have two numbers that are opposites. Adding opposites will give you a 0, which will certainly make my problem easier. So if I put those two numbers next to each other using the commutative property, and then I use the associative property to group these two, I want to add them together so that I can get 0, it leaves me with a very easy problem of negative 3 plus 0. And using the identity property of addition, where adding 0 to anything does not change it, I know that my answer is negative 3. Now let's take a look at this problem. Look at all those numbers. This really looks hard. So what we want to do is pick out the properties that are going to help make this into smaller, easier problems for us to do. I can see that I have several positive numbers, 52, 11, and 31, but several negative numbers, negative 11, negative 2, and negative 12. But I also have two numbers that are opposites. I've got negative 11 and 11. So I know I want to group those together because that's really easy. And I think I'll group the negative numbers next to each other and the positive numbers next to each other because I know that's easier math for me to do. So I'm going to put the positive numbers first without the ones that are going to be opposites, and then my negative numbers, and then the ones that are opposites. I'm going to group the ones that I want to add together using my associative property. So I want to group the ones that have the same signs, and I want to group the opposites and add each of the groups. Now I'm not looking at one big problem, I'm looking at three small problems that are easy to add. So this one is 83 plus this one is 14, and it keeps the negative sign, and 11 plus a negative 11 is going to be 0. And the good thing about having 0 as part of our problem is 0 added to anything does not increase or decrease that number, which is the same thing as saying that it goes away. It doesn't change the rest of the problem, so it drops off, which means I'm really just left with this part of the problem. I have two numbers, one positive and one negative. So I'm going to look at them. The greater absolute value is 83, which is positive. My answer will be positive. The signs are different, so I'm going to subtract their absolute values. 83 minus 14 with a result of 69. So this long, hard-looking problem turned into three small, easy problems and one problem in the end to get my answer.